Okay, grade 9s, this is lesson 3, video 3. It'll be the last lesson for this week. I asked you to do question 2, 3, and 4 in the last video. I just want to make a little note here that if you're working in scientific notation and your calculator tells you that your final answer is 5,00 times 10 to the 0 volts, that's fine as well, because 5 times 10 to the 0 is just 5. Anything to the power of 0 is in fact 1. So 5 times 1 is 5. Okay, let's go through 2, 3, and 4. So for question 2, that part wasn't too bad, that there's calculate the work done in moving a 40 coulomb charge across a potential difference of 8 volts. So this one should have been quite easy because there wasn't a lot of converting to do. So our charge was 40 coulombs and potential difference was 8 volts. They wanted us to calculate the work done. And remember, work done is measured in joules. So W is equal to V times Q, or just VQ. VQ and V was 8. Q was 40. And 8 times 40 is 320 joules. Therefore, the work done is 320 joules. If your calculator was in scientific notation, it would have been 3,0 times 10 to the power of 2 joules. Remember, 2 decimals if you're working in scientific notation. Number 3, a current of 12,000 milliamps. Hope you remember milli means times 10 to the minus 3. Not positive 3, 10 to the minus 3. Okay, so we've got a current of 12,000 milliamps flowing through a circuit connected to a battery which supplies a potential difference, a voltage of 24 volts. Calculate the work done by the battery if the current flows through a time of 20 seconds. So we actually have to do 2 calculations here. Let's write down the information that we've got. So we've got a current of 12,000 milliamps. Instead of milli, I'm going to write times 10 to the minus 3. And on your calculator, if you type 12,000 and then use the exponent button next to your answer button on the bottom, if your calculator is in scientific notation mode, 12,000 times 10 to the negative 3, you should get that it is 12 amps. 12 amps. All right, potential difference was 24 volts. And we need to know what the charge is so that we can go W is equal to V times Q. So our potential difference is 24 volts, but now we don't have W, we don't know what the work is, and we don't know what the charge is. So let's calculate our charge. I'm going to use the formula from page 8. Formula on page 8 says that Q is equal to I times T, and they said that the time was 20 seconds. Please note, guys, in tests and exams it won't always be in seconds. We might tell you that it's 2 minutes, in which case you'd have to go 2 times 60. 2 times 60 is 120 seconds, for example, if we gave you that the time was 2 minutes. This one's nice, there's no converting necessary because it's already in seconds. Okay, so our current is 12, time is 20, 12 amps, 20 seconds, 12 times 20 is 240 coulombs. So our charge is 240 coulombs. Now you can take that 240 coulombs charge and substitute it into that equation. So our work is going to be 24, it's the potential difference that they gave us, times the charge that you've just calculated, which will be 240 coulombs. 24 times 240 is 5,760 joules. If your calculator was in scientific notation mode, you can have 5,76 times 10 to the 3 joules. That's fine as well. Okay, question 4. What must the voltage of the battery be? So they're asking us, what is the voltage of a battery be in order to allow 3 times 10 to the 26 electrons, so that's our number of electrons. 3 times 10 to the power of 26 electrons to pass a point in a circuit in 0,50 minutes. Time is 0,50 minutes. and it's equal to 0,50 times 60 seconds. And that will actually give us, well, half a minute, guys, is 30 seconds. You could have done that in your head. 30 seconds. That's our time. The work is 50 joules. When 50 joules of energy are required, that means that the work will be 50 joules. Okay. So let's work out the charge. Remember, 1 coulomb is an amount of electrons, and that amount is 6,25 times 10 to the 18 electrons. So let's see how many coulombs we've got. So we're going to see how many electrons we do have divided by the charge in 1 coulomb of charge. Think of it as if I told you a box of Smarties has got 10 Smarties in it and you had 50 Smarties. How many boxes of Smarties do you have? 50 divided by 10 would give you 5 boxes of Smarties. So a coulomb of charge is just an amount of charge. That amount is 6,25 times 10 to the 18 electrons. How many do we have? We've got 3 times 10 to the power of 26 electrons. So that gives us 4,80 times 10 to the power of 7 coulombs of charge. And now we can use our W is equal to VQ formula. So our W is 50 joules. And our Q is going to be 4,80 times 10 to the 7. I've run out of space, I'm just going to rewrite this. Okay, so our V will be 50 divided by 4,80 times 10 to the 7, which means that you're going to get a potential difference of 1,04 times 10 to the minus 6, and our units are volts. Please don't ever forget volts. So this one was a little bit more complicated, but I hope you understand that step that I've just circled. It should make sense to you after I explained it to you using the Smartie analogy. Guys, please make sure that when you do these, you have tried them yourself. You don't just copy off from the video. Otherwise, I promise you, you won't learn anything. You have to go through all these questions on your own. Next week, Dr. Thornton is going to be doing the lessons. She's going to talk to you about resistance, and she'll also do investigation 3 with you guys. I would recommend that you try and do it on your own beforehand, so that when you watch the video, it'll make sense and you'll understand what's going on a little bit better than if you're seeing it for the first time. Please also have a remember of how to do graphs. Remember dependent, independent, title of your graph, because you're going to be plotting a graph from your values that you're going to get from the FET circuit simulator. And have a look at the questions so that when she's going through the video, you already know what the questions are going to be on it. Guys, please, once you've watched the videos, I'd like you to let us know if you've got any questions, if you don't understand any of the work, in a private chat or on Teams for everyone to see, and then perhaps other people can help you too, and they might even have the same question. Thanks, guys. Have an awesome weekend. Remember, this is the last video for this week. Dr. Thornton will do lesson 4 with you next week. Bye.